Okay. Can we still hear me? Please, I will need your response so that I will be flowing very fast. Can we still hear me? Blessing Wala, can you hear me?
Yes, 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 we can still
Yeah,
hear
we
you.
can hear you.
Okay, okay. Please, you guys should be responding so that I will know you're following. You're following rather. Okay, I was saying something about the interface here. Here is your files, and then this running will actually show you the notebooks that are running. Currently, I have a notebook that is running now, which is Python basis. If you look at it very closely, and then clusters is in case I have many notebooks and then I want to cluster them into a tab and then I will use this. But this guy is we don't use it often. So the only two places where we um, go into. And then here is when you have a notebook, like I was saying, in case I send this notebook that I'm using to you now, and you want to view it on your own Jupyter notebook, you come here to upload. So when you come to upload, you go to where you have the notebook. I sing this. So we come here to week one, and then you can easily upload. Then it will show here, should you upload? You click on yes, upload. But already I have a file on this particular directory that is bearing the same name. That's why it's asking if it should override, but I don't want it to override, so I will have to cancel that. So that settles that for upload. And then for new, if you want to create a Python file, this is it. You click on new. It will now take you to another tab in that same window of your browser. And taking you to another tab, you will now have something like this. So that settles that for new. You have other files. You have, in case you want to do a text file. Text file is just like a normal text. You can do it on your MS Word. And then if you want to create a new folder, you can come here. And then for terminal, what terminal does is that terminal allows you to install certain libraries that are not inherent in your Jupyter notebook. So in case I want to run a code and I was told that, okay, let's see something. I say import, oh no, my boy. Okay, I'm saying now import ACO. Let's see, import ACO. Okay, ACO went through. So if I want to import something that is not on my device, it will tell me that the module is not on my device. Then I will come here to install it. That settles that for terminal. So once you have your files like this, what you can do is you open it up. Let's open that. We open Python basis. This is what will come up. This is a notebook I've prepared for the class. So this is what will come up. We are having Lenovo Data Analytics for week one. It actually was held on 7th of July. That was last week Friday. And this is my name. So by way of introduction, we went through all these things. But let me explain the interface here to us. This is our file. So if I open this, if I click on file, these are the things that will show. Here means that I need a new notebook. So when you hear a notebook, it means it's a Python file. I saying this, so it's a Python file. And then this open means that I want to open the existing file directory that I was on. Look at this thing and this one, they are the same. So if I want to open, if I click on open, it will take me to that existing file repository. And then save as, when you want to save something, just normal something. And then rename, in case the name you saved it is not correct. All those guys, I think they are easily explained. Preview, print, in case you want to print, then you can download this notebook in this formats. I get to me. Then to trust your notebook means that you want to start it afresh and kill every command and ensure that the notebook is starting afresh. This is it to reload the notebook for you so that it will be entrusted. And then for edits, you have cut cell. So if I want to cut cell, remember for your MS Office or your MS Word is Control X. So you're having a short form of X. So if I come here and I put a a cell here and I want to remove it, I just click on X, the cell will go off. So that is what cut does. Then copy is C. So when you click on C, it will copy that particular cell, and then copy cell above. This is a short form. So all these guys, you just have to go through them and interact with them. The short cuts will help you to beat time when you're using your notebook. So turtle header, turtle toolbar, all those ones are just used to manipulate your header when you're working. And then insert, in case you want to insert a cell above the existing cell, you just click on A. It will insert a cell. So I'm here now and I want a cell above this particular place. If I click on A, it will create another cell here. Are you seeing that? And then that will settle that. And then wait. Okay. If you click on B, it will insert a cell below. So if I click on B, I'll have a cell below. So that settles that. And then we go to cells. We have run cells. So for run cells, it means that you want to run this particular cell now. What we mean by run is uh, uh, we want to execute our code. For instance, I say print, and my device is very okay. Print hello. All right. And then I want to run the cell. I come here and I say run. It will actually do something for me. So if I don't want to always be coming here, I can easily come here and say control enter. It's also run for me. So if you click on control enter, it will run. And then shift enter, it will run and select below. So shift and enter will jump to the next cell below. But if I'm doing control enter, it will just run this particular cell and remain there. So that's what those shortcuts are used for. And then run cell and insert below is alternate enter. So in your PC, if you click on alternate, let's do this. If you click on alternate and enter, it will automatically open a new cell for you. Mind you, all those things that are showing in inputs, they are cells. They are called cells. So that's what we refer to as cells. And then you can decide you want to run all the cells, then you want to run the cells above. These ones are just what you can always go through. And then kernel, what kernel is used for is used to interrupt. Just in case you're running a code, probably you have a loop that is running and running and running and it's not stopping. So you can come here and interrupt it. You can come here and restart. And all these guys can help you to always do that. And then if you want to save your notebook at wicked state, you come here and save at wicked state. Then this guy is for your help in case you want some documentations about um, um, Jupyter Notebook. You come to this help guy and it will help you. And then we have other buttons here. We have save, we have add, we have cut, copy, paste, up, down, run, stop, and then rerun, then fast run, and then here is markdown. So let me explain this markdown very quickly for us before we begin. So here I have a cell. This cell is actually on code. If you look at this place, it's showing code. This is where I'm showing you now. It's showing code. But then if I don't want to write a code, because what a code does is that you have to, a code is a set of program that's, or set of instructions that you give to your PC to actually output a result for you. So I want to say my name is Eben, and then I'll tell my PC print this guy for me. So it will also print what my name is Eben. But if I come here and put this guy on Markdown, what Markdown will do is that Markdown will automatically recognize this print out as a text. So that is what it does. It doesn't perform anything. It just saves it as a text. So what this one is used for commenting, just like I've done here. You see where I wrote Lenovo data analytics. These things are not code. They are just normal English language we know. So that's for Markdown. And then raw notebook convert. Raw notebook convert. It's also it does almost the same thing like Markdown, but what the only difference is that it can easily convert back to note to code. And as well for heading, in case for heading, you see here, this guy is on Markdown, but if you see this first line, this first line is looking more bold than the rest of the text in this particular cell. So the not X rather, the hash, but the hash symbol here is used as my header. So the more hash I add, it reduces the size. Are you seeing what is happening? So if I erase this, it boldens the text I'm trying to look at. So I run this, and then you see what is showing. It's looking beautiful, more beautiful than what we expect. So here is in case you have a lot of commands to study here. So I will leave you with this ones to go through yourself, because we don't have much time by our side anymore. So you study these ones by yourself, and you always practice to use them often. And then here is for your trust. In case you feel your kernel is dead, you can come here to retrust it. So what it will do is it will load um, this entire link again for it to make your work look fresh. So that is what it does. And this Python iKernel is just what is helping your Python to run on Jupyter Notebook. So if you look at normally the Python extension, the Python extension name is IPY. So let's debug that. Python extension is usually IPY, but then for notebook, you have something like for Jupyter Notebook, you have something like dot I dot IPYNB. NB rather. So this guy is telling us that this is a Python file actually, but it's a Python file that is on Jupyter Notebook. So that explains why we are having all this extension in IPYNB. So that is that for the tool we'll be using. And let's go on for the game of today. So introduction to Python programming. Under Python programming, the basic thing you need to know first of all is the data types, the data structures. What are data structures? And then arithmetic operations that can be done with Python, control flow. You need to understand that very well. And then we have functions, we have modules as well to deal with. So in week one, we are getting to introduce the basics in Python programming and the key things we need to know in Python programming for data science. So that is what we are here to do, Python basis. So for as a way of introduction, I want to say that Python is actually a general purpose programming language. Why we say it's a general purpose programming language is because you can use it to do anything. You can use it to do anything. You can use it to build a website. You can use it for software development. You can use it to conduct data analysis. Remember, you before you go to analytics, you have to transit from data analysis. So it can also help you to conduct data analysis and as well analytics. It's analytics that has to do with forecasting the future events. And also it can be used to create varieties of programs to solve problems. So one thing with Python is that it allows varieties of programs. You can use it in if you're in mathematics department, if you're studying mathematics, you can use it to solve problems that are related to mathematics in any area of in any field of study where you find yourself. You can easily use Python to solve problems there. And as well, it is the most used programming language. I get me. So it became the most used programming language recently because of how simple its syntax is, and as well, its user friendliness is what is another reason why it became the most used. So by as a way of trying to understand more, we said that it was created by this guy and Gadio van Rossum, and it was released in 1991. That's when we heard of Python first. So we'll be looking at data types. I already said that you have to understand data types, and there are four major data types used in Python. So in anything you're going to do, whether you are going to use it for software development, whether you're going to use it for website development, whether data analysis or data analytics, you should note that there are basically what four types of data types. And then the first one is integers. So integers are just what numbers. They are just numbers. When you have a whole number, like a counting number, in base 10, because numbers in base 10 are just zeros to nine. So when you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, those numbers are regarded as integers. They don't have decimals. And then we have floats. So what floats are? Floats are actually numbers. But what distinguishes float from integers are the decimal points. Floats have decimal points, and that part of it decimal, or that its decimal part, is what is referred to as the float, because we Python sees it as numbers that are floating. So do you understand? That part that has decimal points, in fact, Python sees it as was numbers that are floating. And then another thing is strings. When we look at strings are purely letters or alphabets. Whenever you see letters or alphabet, they are called strings. So, but there's another unique thing about strings, is that strings could be numbers, but those numbers or anything that is enclosed in a quotation mark. So whenever I have something enclosed in a quotation mark, either a single quotation or double quotation mark, those things that automatically become strings. So that's for string. And then we have the last one, which is boolean. This they are either true or false values. So whenever you have a true or false value, that is a boolean. So what's boolean actually is from this theory of logic gates, where you have a true or false kind of a result or kind of inputs, and then you have your results being 0 or 1. So that is where we have boolean originating from. And then another thing we should take note of, don't mind, we'll still have some codes to digest. If time permits us, we should digest some codes that will help us to understand this guy more. So we have data structures. Under data structures, we said that data structures are used to store multiple items rather, in a single variable. Okay, so explaining this is that data structure is just like a container where you have different types of data coming into that container. So I could have an integer, I could have a float, I could have a string, I could have a boolean, all inside one variable. So what helps all these data types to be accommodated in that particular variable is what is known as structures, data structures. So the first type of data structure we have is list. Then the second one is tuples, the third one is sets, and we have dictionaries. We'll explain them further. Let me rush up these ones. And then we have arithmetic operations. Remember, I told us we will be touching applied mathematics. So you cannot do mathematics if you've not done arithmetic operations. So arithmetic operations has to do with addition, subtraction, multiplication, division, exponential, and binary. This one is very, very important. And then we have whole number division and remainder division. So we explain that when we go down the notebook. And then we also have Python conditional, where we have iterators and as well control flow. So under the conditions is where we'll be testing if a particular quantity or variable is equal to the other one or not. And that is what will help us achieve the conditional test. And then for iterators, we have if and if statements. So if statement, what if statement helps us to do is it tests a condition and executes a block of code if the condition is true. So remember, if statement can only be executed, or the conditions, the block of code in if statement can only be executed if the conditions are true. So this is a typical illustration. I used it last week. I was saying that, okay, you're sending a child to help you get let's say a biro, and then you're telling the child, if you get to the shop and there's no biro, please come back. So that is what the boy will do. When the boy gets to the shop, they say there's no biro, the boy will not buy the biro. But if the boy gets to the shop and the seller says there is a biro. That biro now is the condition. Is there a biro? Yes, there's a biro. So that condition has been met, which is true. The boy would easily what purchase the biro with the amount of money you give to him, and then that means that block of code, that condition is satisfied. The block of code will now do what run, which is the output you're getting in return, which is your biro. And then we also have something called Python loops. Under Python loops, what we are considering under Python loops is executing a block of code repeatedly as long as a condition is met. I get me. So long as 8 p.m. to 4 a.m. is night, people must sleep. So that is a condition that must happen every day. So you have to be sleeping at night. So long as it's night, you must sleep. Even if you're this kind of person, you're passionate about success, you definitely have to sleep in, even if it's 1 hour or 2 hours. So that is a condition. Once that condition is met, you will continually execute this block of code repeatedly. So that's for Python loops. And then we looked at functions. So what functions are? Functions are just like um a sample we build in order for us to reuse them later on. So when you have a block of code that you want to reuse to perform a specific task, that is when you say that you have a function. And then also it helps us to organize our code very, very well. So let's try to understand data. Let's try to understand data types. The first one we said is integers. And then for integers, we have numbers, we have floating numbers, we have letters, we have booleans, which are true or false statement. So for those ones that are true or false statement, we call them booleans. So let's try to see examples of what we did last week. The first one here is we have a variable name called x being equal to 2. All right, this is what I explained. I was saying that if I have something like this, sorry, I have x being equal to 2. This x itself is called a variable. And then this 2 is a value that is assigned to this variable x. Are we together? So this variable is what? X, and then this is the value assigned to x. So when we want to check what data type is x, we now come and say type x will give us what? Int. All right. So going back to this guy, you see where I wrote int, you see where I wrote float. So this int is a keyword for integers. So whenever I have int, it's pointing me to the fact that the value I'm looking at is an integer. And then when I have this keyword float, it's pointing me to the fact that is what a floating number. And then str is a string, while bool is a boolean. So that explains that for integers. And then that's the same thing we have here, so we don't have to repeat that. And then we now look at floating numbers. I was explaining something. I said that if I have y being equal to 12.0 and I check the type of data or the type of value which this y is carrying, you see that it's a float. But in real sense, or in basic mathematics, you'll be told that 12.0 is the same thing as 12, but then Python will identify 12.0 as a floating number because of this decimal. I get me. And then it will also identify 12. Let's see if it will identify 12. Let's say A is equal to 12. And then, sorry about that. Let's check the data type. Data type, type of A is going to be what? An integer. So you see now, we have a float, we have an integer. But there is one funny thing that Python does. If I say 12.0, is it equal to 12? Python will tell me, yes, it's equal to 12. So that is one crazy thing I've not understood yet. Why this guy is a different data type and this one is a different data type. But you now um you now agree with yourself that you were correct when you said that 12.0 and 12 is the same, but they are not the same. They are not having the same what data type. That explains that for that. And then we now looked at strings. Strings. Remember what we said about strings? That strings are what? Letters or alphabets. And then if strings are letters or alphabet, it means that if I have a variable name called my name, this my name is a variable. So whenever I am looking for my name, this value which I've given to my name, which is Ebenezer, will come up, right? And then I'm having this guy, this value stored to this my name. And then I want to look for the type of data. Mind you, when you type or when you are using words in Python, and they tend to show you a different color. Look at this, the color of this text is showing kind of green, and then this one is the normal black, and this is reddish and all that. So this one is telling you that this guy is actually a variable name, and then this one is a keyword, while this one is indicating is a string. So that settles that. So this variable name, I want to check the type now. Checking the type, it will tell us that is what? A string. I think this. So we're having a string here, str, str. So we're having a string. That settles that for saying that alphabet and letters are actually strings. So, but let's verify if actually um whatsoever is in quotation mark is a string. So let's use 12.0 and let's see what is the data type for what is the type of AB. AB. The type of AB is now what? A string. But remember when we when we checked here, where did we check that? Okay, here we had it to be what? A float. But then we are now trying to affirm that whatsoever is inside a quotation mark, be it a single or double quotation mark, if I'm using double, it will still show me the same thing. So that settles that for that. And then when I have a true value, so I have z being equal to true, and then what type will it be? Remember, boolean. Boolean is what? True or false statement. And then I was trying to explain about formatting here. For instance, I want I want I want to print this text attached to my name. Remember, I gave my name a value, Ebenezer, and then I'm saying that I want my machine to print out my name, but I will not tell the machine my name. I will only give the machine my variable name, which is my underscore name as the variable name. And then when I do this, what will come out is my name is Ebenezer, because the value attached to this my name coming up here is what? Ebenezer. So that's one is for formatting. This is called formatting. It means that I'm not I'm trying to hide I'm trying to hide the value that is needed here, or I'm trying to there's what I'm trying to remember. I'm trying to intertwine this the value to my variable name, and then it will print out what the actual value that was attached to this guy. So that settles that. And then here we had a whole lot of things to do, just a kind of a compilation of what we have discussed individually. Here we have integer, here we have a float, we have a string, we have a boolean and another boolean. So if I run this code now, we'll be seeing all this guy expressing what we have. So 2 is for integers, floats, 2.0 is for floats, Ebenezer and Anium is for strings, and then boolean is for true or false statement. So that settles that for data types. And then we already go to data structures. Let's look at, hope we are still following. Please confirm we are still following. Let me be sure I'm not talking to myself. Are you still hearing me?
Yes, we can hear you. But I think some people
Okay,
are
okay.
still waiting for you to. the class. I don't know.
I'm sorry about that, please. My internet device just went off, so I had to take another option. All right, let me continue from where I stopped. Sorry, please, guys. All right, please confirm you can still see my screen, please. All right, thank you very much. Okay, we wanted to start data structures. So I was saying that data structures, under data structures, we have four categories of data structures. And the first one is list. So what list? List is just use, oh, sorry, let me say lists are created using square brackets. I have to come back to record this, please. Is it still recording? Okay, yes, it's still recording. Okay, they are created using square brackets. So this is what we call square brackets. And then one unique thing about lists you shouldn't forget is that lists are ordered, they are changeable, and also they allow duplicate values. So lists are ordered, they are what? Changeable, and as well they allow duplicate values. So when you create a list, always remember that your list automatically will take an orderly manner, and you can easily change the variables or the values in your list, and as well you can have multiple values in that particular list. And we have another one known as tuples. So what tuples does is that tuples are created with curve or round brackets. So this is how curve or round bracket looks like. When you create a tuple using a curve or round bracket like this is it. And then these things you should note is that they are not immutable, or sorry, rather they are immutable. It means you cannot change anything in tuple. So if I have a value in a tuple, I cannot change it. And then the items are also what's ordered, and they remain unchangeable, just like we said, but they are allowed for duplicate values. So I can have the same value repeating itself in a tuple. And then the next thing is we have a set. Set, just like we know of set in mathematics, set is Sets are created using curly brackets. So when you make use of curly brackets, you are definitely creating a set. And then the next thing you should know about sets is that they are unordered. They don't take a particular order when you're creating a set, and then you cannot index a set. All right, explaining index, let's have this here. Index means we okay, let's have a list of let's have colors. We have colors, and then list of colors. We have the first one being what? Blue. We have red. Yeah, red. And then we have yellow as a color. All right, so this actually is a list. So if I want to check this, if I want to check if this is a list, I can also do type of color. Remember, your type function helps you to check the type of uh uh the type of data structure which your variable name is. Why we had that error was because I didn't spell color correctly. I had colors here and I was using color. So I have color. So it's telling us that this is a list. The first reason is because this is a square bracket, this is a square bracket, right? And then what I mean by index is for this particular list, the index number here are, let's say, color index. So for the first value, I will have an index of what? 0. Are you getting me? This blue, the first value in any of your data structure is usually having an index value of 0. And then the second value will have an index number of 1. And then the next one in that progression will be having an index number of what? 2. So this is true because if I want to call out this blue without mentioning its name, I can easily say, let's have this be print. I can easily say print print this. So let's have print we want colors, then underscore 0. So this will give us what? A blue, right? Are we seeing this? Please confirm you can still hear me. I think my network is being interrupted again. Can we still hear me, please?
Yes, sir.
Yes, we can hear
Okay.
you.
Okay, so this 0 is telling us that we're actually picking blue. So that's what indexing is all about. We are not calling the values itself, we are using its index number. But if I call 1, if I choose 1, it will be giving me what? A red, right? So that's for indexing. But if I'm creating a set, let's look at a set now. Let's look at a set. We have a set. Let's say we have this same guy being a set. The only thing we have to change here is the bracket. We are using now a curly bracket. So if we use a curly bracket, we'll be having this. So let's check the type first. Remember, you always have to check the type of your data structure. So it's a set now. So we're having colors. Let's use this with color sets. So we have color sets to be what? A set, right? And then let's try to see if we can index in color sets. So we are calling the variable name color sets, and then let's try to index. You see there's an error. The error is telling us that set object is not subscriptable. So you cannot use the subscript of a value in place of that value when you're dealing with sets. But In all others, you can always use the subscript value, which is also known as what? The index value. And then they are unchangeable. You cannot change anything here. Once you have a set, you have a set. And another thing is that once a set is created, you cannot change the items, but you can only add, and duplicate is not allowed. Duplicate is not allowed. So in case I have, just in case I have blue, red, blue, sorry, blue, red, yellow, and I want to include another blue like this, I will, if I come here to print out my color sets, this is what should be showing. I see this. This is what it's showing now. Blue, red, yellow. So the last blue is not showing because it's a duplicate. What it means by duplicate is appearing more than one time. Are you getting me? So once it's appearing more than one time, the set itself will pick the first one that appears. This is the first blue, and then it's followed by a red and then a yellow. So it will go by blue, red, yellow. Are we together? So this will help us account for why we said sets are duplicates are not allowed in a set. And then we go to dictionaries. Dictionaries. Under dictionaries, we have they are created using coily brackets, the same way this guy. But one unique thing about dictionary, or one distinctive thing, is that they are used to store multiple items, and those items are usually in keys and in values. In key and in value. Okay, this is how a dictionary looks like. I was showing us the other day that if I have my dictionary. So what my dictionary does is that it explains in a literal term rather. Dictionary, what dictionary does is that it explains further what something is, right? That's why we go there to check meaning of stuffs. So if I want to know more about myself, I can easily stock it up in a dictionary. So I have a first name here being, this is my dictionary. Let's create this afresh so that we understand what we are doing. And then we have a coily bracket. This is it. And we have a key known as my name, and then we have a column. So this column is what distinguishes the key from the value. The key from the value. So I have a value attached to this, which is, let me use even, and then I can also have another key. I can also have another key known as my gender, and then what gender is even? A male, I think. All right. So let's explain dictionary now. Let's always remember what is on your left hand side is your variable name, and then the equal to sign is just showing that there's a value attached to it. So in the dictionary, we have the coily brackets. That is true. But there's another thing we have, a key and a value. So this is a key and a value. So look at dictionary to be something that stores another variable inside of a variable. Okay, we already know my dic is a variable, like my dictionary is a variable name. And then I'm having my first name to be a variable name as well. So for the first name, it means that the value to be attached to this first name is somebody's first name. I get in this. And then inside that dictionary, we also have a gender, which is telling you what gender that person is made of, either a male or a female. And then this is a male now, right? So if we want to check this type of data structure, it will tell us what is a dictionary, DICT, which is the short form of a dictionary. All right. I was also saying that day that we could have multiple values attached to a single key, a single key. So these are the conditions for creating a dictionary. we can have multiple values, but just what? A single key. So this is the key, and then this is the value. So here we're using a variable name, which is first name, as our key, and then we're using a list of what? Of people's first name. So that day we had Ebenezer, we had Matthew, we had Caleb. These guys are actually what? First name of persons, right? And then we also had surnames. We also had what? Surname as another key. So this other key now will be saving the person's surname. Are we together? And the nationality, we also had something about nationality. We had a Nigerian for the first person, I think, and then we have Italian for the second person that was on the call, and then we have a Nigerian again. And then this, if I print out this dictionary, this is what it's going to show. So one beautiful explanation you need to understand is that the first person's, the first value here goes with the first value here, and at the same time with the first value here. So it means that each of this key now is having the same index number with those values. So if I want to get Ebenezer as a name, I'm using what? An index value of what? 0. Are we together? And then if I want to get this one, I'm using an index value of 0 as well. If I want to get this one, I'm using an index value of what? 0. So let's try to see if we could get all these things I'm saying. So we are indexing now. I have my, and then this. Remember, if you want to index a dictionary, you consider the key first. So what is the index number of this first key? 0, right? So we have here 0. Sorry, this is 0. And then we now go into the values. What is the first value there? 0. Let's call this out. So we have a key type error. So we have the first name, which is first name, please. And then what will be the first letter in this first name? Eben. Are you seeing this now? We didn't run this code. That's why. So we're having this to be what? Ebenezer. Is there any confusion, please? We are having the first, this is our variable name, my dictionary. And then I'm calling the first key, which is first name. And remember our indexing we talked about 0, 1, and 2. Are we together? So if I'm having 0, 1, and 2, this means that if I'm calling 0, the first name should be appearing. And then if I'm calling 1 or 2 rather, it means what is for Caleb. And then if I'm trying to look out for their surnames, and I'm calling 2, the third surname will show. That's to tell us that this third first name goes together with this third surname. Are we following now? So that's for dictionary. So we had several examples that day. We said that days of the week, when we have days of the week in a tuple, remember a tuple allows for multiples, and then we now try to check the same days of the week in case we have a set. So let's change this now to a set, which is curly bracket. Please reserve your questions. We'll start answering questions very, very soon. So if you have a set like this, your days of the week will now be only Sunday and Monday, because we are having Monday to repeat itself twice. Well, that's tell us that it doesn't allow for repetition. So we only work with what is not a duplicate. So that's for dictionaries and tuples. So we have a whole lot of things for you to interact with when you get the notebook. And then this one, remember this, when you have a number alone is what? An integer, and then you have this as well. All these were the explanations we did. We've done them now. and then we're trying to convert. Here we're trying to do what? Convert from one data type to another. So if you want to convert from one data type to another, let's say for instance, um, I have a string or an integer, which is x equal to 3, being an integer. Look at this, x is 3. And I want to convert this integer to a string. I'll just say x of string will be str. This str is just a keyword of string. So I'm saying that string this number for me, and then it will become what? A string. And then if I check str, remember, a number that is a string has to be includes in a quotation mark. That's why we're having this guy includes in a quotation mark. And then if you want to convert it back, you make use of the keyword int. Int will be the keyword to be used. And then that will settle that. The same thing applies to my name. Remember the variable name, my name, it was having a value of what? Ebenezer. And then we're trying to see if we could convert alphabets back to integers, but it was not possible because remember what we said about integers. Integers has to be numbers that are in base 10, but this guy Ebenezer is not in base 10. That is why he's not a number. So that settles that for the explanation we need to know about changing from one uh, variable type to another. So let's head to arithmetic operations because we are really running out of time. We have addition, subtraction, division, multiplication, and all these guys. So addition, your normal plus sign will help settle addition, and then subtraction, your minus sign is there to account for that. Your division is now being used, the forward slash is what is used for division. And then we also have something known as multiplication. In multiplication, what we do is this is what we do in multiplication. Instead of us to use the normal cross x, we make use of what? Asterisk. So we say 5 times 4 should be giving us what? 20. And then we have something like exponential. What exponential does is it's just like when you're looking at the square of something, or the a number raised to a power of another number. So let's say for instance 2 exponential 2 should give us 4. That is 2 raised to power 2 is 4. And then 2 exponential 3 will give us what? 8. So that's what exponential does. And then binary almost does the same thing with exponential, but it's beyond the scope of this our training. And then whole number after division. So this is whole number division. Whole number division has to do with when you divide a number that normally is not divisible, or it will give you a remainder. What whole number division will do is that it will output the remainder. Sorry, it will output the whole number part of your division. So let's have this. We are having 5 whole number divided by 2. This will give us 2, because we know normally that if we divide 5 by 2, it will give us 2 remainder 1. So it will now give us what? The whole number part, which is 2. And then we now try to divide the 2 using the normal division sign, which is single forward slash. It gave us what? 2.5. So when we have this 2.5, you see that your whole number division only outputs what? The whole number, which is 2, and leave this other side, which is the remainder part. And then the remainder division will return the remainder part and leave the whole number. So the remainder division part makes use of percentage as its sign or symbol. So if I divide this guy, it should be giving me what? 1, other than the normal 2. So it's giving me the remainder that was gotten from dividing 5 by 2. So that settles that for mathematical operation. So there are other things, keywords we need to note in mathematical operation before we rush down to the that one. We have sum. Under sum, in case I have a set of numbers like we have here, right? Like this, we have 3, 5, 7, and 8, and then I want to look for the sum of all these numbers in together, just a single value. So I will use sum and then open a bracket and then put these numbers in a tuple, right? And then when I click on run, this guy will output what 23 for me, because I know that 3 plus 5 plus 7 plus 8 is outputting what 23. And as well, we can save numbers in variables. These are variable names. This variable name is having 3.0, this variable name is having 3, and then we are doing z plus y to output what 6.0 for us. And then also another thing I remember to input was the minimum value. So when you're looking for minimum value has to do with checking out for the smallest number in the range of in a range of or in a set of numbers rather, or in a set of digits. And then the minimum number here is what 3, and then the same thing goes for this guy. If I'm checking for the maximum number, it will give me what 8, which is actually the largest number our in our list of numbers. So this is where I give example of whole number division and remainder division, and then power exponential division. So the next important thing we should take note of, please pay attention very well at this particular point. We have Python conditional iterations and operators. So for conditions, first we are testing if there are actually 6 ways of testing for a condition. The first thing is you test if the conditions are equal. So if they are equal, and then you know that it will always do what outputs a true. Remember our Boolean rule. And then you can also test if operations are not equal. That's I'm saying that a variable A, is it not equal to B? So this is the sign you use for not equal to. An exclamation sign together with an equal to sign. So for equality, or checking if two variables are the same, you're making use of what two equality sign. And then if I'm looking for a less than, I want to see if this variable is less than the other one, I'll use what the normal less than sign. And then if it's less than or equal to, I'm using what's this less than and then equal to. So what less than or equal to means is that this value A can actually be smaller than B, but as well can be B. So if I'm taking a range of those values, it will mean that I'm taking set of values from B downward. So that's what this less than or equal to is means. And then we also have greater than. So this is greater than. A is greater than B. So it means that A is great and bigger than B. That's just a literal meaning of that. And then the same thing happens for this one. So we have what's that there? We have greater than or equal to B. So this is where we're testing for some conditions. I said is 10 greater than 3. Of course, 10 is bigger than 3. So your machine will tell you true, that is greater than 3. And then we now said, is 200 being an integer the same thing as 200 being a string? Your machine will tell you no, because we know that a string and a number can in no way be the same. So if you're measuring if you're evaluating the quantity, they are not always the same. So a string cannot, in a number cannot be the same thing as a string. But we can have a number, and also we have a decimal number. So it is normal, it is purely true that 200 can be equal to what 200.0. So another type of conditional statement we need to note is the if statement. So if statement, like I explained, is when you're testing for a condition. If the condition is true, your code will run. So we had an illustration that day that we have a set of we have an age which is equal to 20, and then we are now testing that if somebody's age is greater than or equal to. But if we have, let me say something like 24, you will see something like you are an adult, right? So this condition, which is age being greater than or equal to 18, is true. That is why the next code has to be what executed. It's just like you say, okay, if you say, you say what?
We can't see your screen again. Okay, it has come back.
Can you see my screen now?
Yes, sir.
Yes, yes, I can see.
Okay, please, sorry about that. It's network issues. Okay, so we're still on this guy. We're saying that if this condition is met, it means that this particular block of code is going to run. So when we give our age a value being we give age a value being 24, and then we now tested, is 24 greater than 18? Yes, of course it's greater. So print that that person with the age 24 is what? An adult. And then if we now go back to say we have somebody that is 10 years old, so if you now enter an age which is 10, it will know what? Print. Are you following? So this is what happens when you're given a condition. The condition has to be satisfied or true before the block of code is executed. And then another thing is if else statement. So under if else statement, remember when we had age being equal to 12, um our Python did not do anything because we did not tell Python what to do when the age is less than 12. But then there is something that can account for that, which is the else statement. So else statement is that if this guy, the first condition is not true, please help me execute the next one. So this is it now. Age, if age is greater than or equal to 18, the next statement is what? Prints that the person is an adult. Else, that means this else is telling you that it means that if this person is less than 18, please print that the person is what? A child. So we can, this one now can account for when we have 12 years old person, right? So we are now having what? A child in the game. And then we still say, okay, what if we want to consider a range of, a particular range of values? Let's say, for instance, a grading system in a school. You have A, B, C, D, and F. And then I want to see people that score from 90 and above should have A. We are testing actually. So the condition for the first one is if people that score 90 and above, give them A. So that's one. What will help us arrange that code very, very well is if, elif, and else statement. So if elif and else statement are three different block of code that needs to be written, and then they have different conditions as well. So if I'm testing for the first condition and it's not met, I can easily go to the second condition with the help of elif, and then it will execute this one. If it still doesn't work, I can still have another elif statement to test for the third condition. So that is where the grading system idea came into play. So I have a score. I'm saying that if that score is greater than or equal to 90, please print that the person's grade is what? A. And if the person scores below 90, that is around, if the person scores from 80 and above, that person should be having what? A B. Are we seeing this? that person should be having a B. And then the same thing goes for 70. This is not actually any school grading system. I'm just doing this for us. So once somebody has 70, the person is having what? A C. Or 71, the person is having what? A C. So this one ends in 79. And then once it gets to 80, the person should be having a B. And then the same thing goes for this one. And if the person scores less than 50, that's the ultimate condition, or the ultimate rule should be executed, which is print F. So let's test this again. We have somebody scoring 20. Let's see what the person should get. The person should be getting an F. And then if you see somebody that scores 98, what does the person have? An A. So you now see, if you see somebody that scores 70, let's see what somebody that scores 70 will have what? A C. Are you seeing this now? So that is what um if statement helps us to achieve. And then the next thing is loops. Under loops, we have that loops are used to execute a block of code repeatedly as a condition is met. Remember what we explained, that so long as it is night, people will always have to sleep. So that condition, that once the day falls, people will have to sleep. And then the condition is in form of a sequence. So when we have items in a sequence, and then we want those conditions to be met, and then once those conditions are met, we now have our code to run. So I have a list of fruits here: apple, banana, and cherry. And then I'm saying that, okay, for each apple or for each fruit in this list of fruits, remember my variable name here, fruits. And then I'm saying for each fruit in this list of fruits, print fruits. So note the spellings here. For fruits in fruits, you print what? Fruits. So I'm printing each of the fruits here. So long as there is fruit in this list, it will continue to print it until it gets to the last one. So that's for that. So we're having this, and it will run. It will be printing what? Apple, banana, and cherry. So that's one set also that. And then we have also odd numbers. Odd number. Okay, this was something I was explaining about range. So if I have a range of values from 1 to 10, and I want these values to be odd numbers, it means that I will give it a step of 2. This step of 2 means that if I have the first value being 1, the next one should be what? 3. And after I have 3, the next one should be what? 5. And the next one should be 7 and 9. So those ones now produce an odd number. So if you have a problem that you should write a code to print odd number, this is just a very best solution to the problem. So when we want to iterate through this range of values, what we do is, for I is now an integer in the range of this guy 1 to 10 with a stepwise of 2. Print I. So it will first of all print the first value, which is 1, then print the second value, which is 3, 5, 7, and 9. So that's for for loops. In case you have a question, also keep us in touch. We are out of time. So let's round up with these functions we before we close. So a function is a reusable block of code that performs a specific task. Then functions helps in gathering and in organizing. So what function does is that it's actually a block of code. So this is how to write a function. You start with def. You're defining a function. Def means define. So you want to define a function. So if you're defining a function, you have to give your function a function name, followed with parenthesis, which is a bracket, square. It's not a square bracket, sorry, please. It's a curved bracket. And then your parameters should be inside of that bracket you opened. So these parameters are actually what you're going to use to in your code here. Somebody have a question? Chukudi, your hands are up. Do you have a question? Please, Hold on. When we are done, we will answer your questions, please. Please. All right. So we're
I
saying
can't
that
see your
if
screen.
we have, can you guys see my screen? Please, if you cannot see my screen, exit the call and rejoin. You will see my screen. All right. So when we have this first line written, the next thing is what you want to do, the code that you want to it to solve a problem, and then you now return the solution of
Okay.
the outputs of your solution rather. The output of your solution. Please, let's avoid distractions. So here I was explaining Python inbuilt function. This function is called print. Whenever you call print, it will produce something. So if I say print 1, I will see 1 as an output. So we want to write a function that will have a name as well. So here we define the function add. This is our own function we are defining. We have add. So we are adding, this is a variable A, another variable B. So we want to return now, add A plus B. So let's have this as a code. Let's say addition is equal to A plus B, right? And then let's return addition. All right. When we run this code, and then we call the function name. Remember the function name. This guy is the function name add. When we call the function name add, we have two parameters inside here, 3. So we have 3 and 3. So it means that it will add the 3 of them together. If I want to add 4 and 5 or 8, it will still add the both of them together. Reason is because I gave it a task to do here. I said addition, add these two guys together. So it will add the first parameter to the second parameter, and then it will return the solution of the addition. This is it here standing. And then the same thing goes for this place. If you want to, you can use this function name anywhere. So here we're saying results. We want the result of the addition of 3 and 4. So if I run this code, it should be giving me what? 7, because I'm using my function name known as add here. And then there's another thing known as augment function. What augment function does is that you will not have to put a parameter here. Are you getting me? You don't have to put a parameter here. What you need to do is just you type arg. So arg allows you to put any type of parameter in this place. But here we're only limited to 2 parameters. So if I should put add 4, 8, and 2, our code will not run because it will tell you that there's a type error, and that type error says your add function takes only 2 positional arguments. I think this, but we gave it what? 3 arguments here, so it takes only 2 while we give it 3. So we have to always limit ourselves to 2 when we are dealing with self-defined function. And then when we are working with augment function, we don't need to input parameters, like I said. So I can easily add as much as I want. I can add 10, 2 again, or 28. So if I add all of this, it'll be giving me what's 49. The same thing goes for lambda function. Lambda function is another type of function that helps us to perform mathematical operations. We have x times 6. But before we have x times 6, we call lambda. So lambda is a Python function. It allows you to save a value, an unknown value, x, or any unknown value of your choice, and then followed by a column. This column now is telling you that what do you want to use this value you've given lambda to do. So this is the value, and then this is what you want to use that value and do. So whenever you use this value and do something, whenever I call lambda, which is, or lamb, which is my variable name, and then I impute, I give it a value, I give this variable x a value 20, it will always operate on this. So this is now going to be 20 times 6, which is giving us what? 120. So we can have it to be 2 times 6, which is going to be what? 12. So that's what lambda does. So you can also use it to perform squares, like x raised to power 2, sorry, x raised to power 6. So if I have x raised to power 2, let's say for instance 7 raised to power 2 will give you 49, and that's for the basis of Python programming. So I don't know if there might be questions or things you don't understand. I am very much open to answering questions now before we end the call, because we have to join the call again by 8 for our last class for today. Is there any question, please? Is there any question? Why is
The question was the video for the last slide is it the same thing as this one?